everyone. My name is Gladys Rama, an editorial director. Thank you so much for being here, and welcome to today's summit titled Level Up Your Cloud Security with Zero Trust. This summit has been brought to you by 1111 Systems and Hewlett-Packard Enterprise and put together by the hardworking staff at Virtualization and Cloud Review. So we really hope that you enjoy it. Before we start today's event, we do have a couple of announcements. First, we want to let you know that this event is being recorded and will be available for future viewing. You'll get an email from us when the replay is available, generally within the next couple of days. Second, each of today's two sessions will be followed by a 5 to 10 minute Q&A. So as your questions come to you, please be sure to type them into your console, and we'll try to get as many of them answered by our experts today. Finally, during today's second session, we will be giving away a Fitbit Charge 6 Advanced Fitness and Health Tracker, but you have to be present to win, so be sure to stay on for the entire event. And I was kidding, this is the final announcement. We do have resources from our sponsors, 1111 Systems and HPE. They're available right now on the console for you, so do check those out. Contact them afterwards if you have any questions after the event. It's because of 1111 Systems and HPE that we can bring you this summit, so we thank them so much for sponsoring today's event, sponsoring the community, and we ask that you check out those resources so we can bring you more events like this in the future. Now on to today's first session. This one is titled Why Your Cloud Needs Zero Trust and How to Implement It, and it features Brian Posey, a frequent speaker here with us, a 2022-time Microsoft MVP and a longtime technology writer on Resin magazine and Virtualization and Cloud Review. Throughout his career, Brian has written or contributed to dozens of IT books, created numerous full-length video training courses, and published thousands of blog posts on a huge variety of IT topics, many of which can be found on, as I mentioned, Virtualization and Cloud Review and redmondmag.com. Brian, I'm going to give you the floor.
Hey, thank you so much. Hello, greetings, and welcome, everyone. And incidentally, with regard to the introduction slide with the commercial astronaut candidate thing, there is an area, or there are occasionally areas where my IT background and space background converge. And I've actually been working on one of those recently. I'm working on a project that's going to involve a HoloLens 2 device and a Surface 2 device. And I can't really go into all of the details right now, but that's hopefully going to be flying on the Vomit Comet in zero gravity flight later this year, and then potentially in suborbital space after that. So exciting stuff. But let's go ahead and get started. Now, the first thing that I wanted to start by talking about seems way out in left field, like it has absolutely nothing to do with my presentation topic, but there is a method to the madness. And what it is that I wanted to talk about was one of the more negative aspects of the IT industry, and that's the use of buzzwords and fads. Now, in all fairness, every industry has buzzwords that it uses, and IT is no different. But the problem that I sometimes have with buzzwords is that they can lose their meaning over time. I could point to countless examples of that over the years. The other thing is fads. Sometimes in IT, you'll see the entire industry get behind a trend, even if it doesn't necessarily make sense for individual businesses, just because that's what we're all, quote unquote, supposed to do. For example, consider a decade ago, the mass cloud adoption. Seemingly overnight, everyone decided that they had to be cloud first. It didn't necessarily matter if it made sense for the business. It was just really smart people were saying we all need to be cloud first and have a cloud strategy, so that's what we're doing. Now, certainly that didn't happen in 100% of the situations, but it was pretty widespread. Now, why do I mention all of this? Well, it's because of the whole zero trust thing. When I first started hearing about zero trust, maybe a year and a half, 2 years ago, something like that, it kind of seemed like maybe it was destined to become another one of these IT buzzwords, like the whole big data thing or something like that, or that it was going to be another fad that everybody latched onto, whether it made sense or not. In retrospect, however, it ended up being the absolute opposite. So my point in saying all of this is that I consider zero trust to be one of these things that's super important. As a matter of fact, I would consider zero trust to be absolutely essential in today's world, given the state of everything. So I would encourage you to begin looking at zero trust options for your organization if you haven't already, and not to be concerned that maybe it's just another fad that everybody is doing and that it doesn't really have any place for your organization. So all that is to say that zero trust is extremely important. So having said that, what am I going to be covering today? Well, I'm going to begin by spending just a little bit of time talking about what zero trust is and what it isn't. And I'm sure that most of the people who are listening to me today probably have at least some concept of zero trust, and that's great. But there are two reasons why I want to spend just a few minutes at the beginning talking about what zero trust is. One, remember what I was saying about all of those buzzwords and there being a bit of ambiguity behind that. I've run into that so many times over the years with different technology terms. I don't want to spend a whole lot of time on this because I've got a lot to cover, but just one example. When the big data trend came out quite a few years back, somebody asked me to write an article on it, and I don't even remember what I covered. I believe it was something database related. And they got back to me like, what is this? Everybody knows big data is about high-def video. So there's that breakdown about everybody had different ideas about what big data was. Well, I'm seeing the same type of thing today with regard to zero trust security. Everybody seems to have slightly different ideas about what zero trust is. So spending a few minutes at the very beginning talking about what zero trust is and what it isn't, that kind of helps to put everybody on the same page, and hopefully will make the remainder of the presentation make just a little bit more sense since we're all coming at it from a common angle. So what then? From there, I'm going to talk about why zero trust matters. I'll go into some of the core zero trust principles, and then I'm going to spend the bulk of the presentation talking about some best practices for zero trust in the cloud. And I'm going to be doing this almost exclusively from a vendor agnostic standpoint, so that hopefully those best practices are things that you can put into play regardless of which cloud providers you're actually using. So let's go ahead and get started. So what is zero trust and what is it not? Well, zero trust isn't a product that you can go out and buy or a service that you can subscribe to and then all of a sudden you're zero trust. It doesn't really work that way. Zero trust is more of a philosophy. It's a way of doing things, or it could even be described as a framework. So the overall idea is to make it so that nothing is trusted by default. Instead, you're verifying and re-verifying everything on your network. And it's not one of those points that you're going to get to instantly. It's one of those things that happens over time. But ideally, as you bring new security mechanisms onto your network, you take a look at how they plug into that zero trust framework and work towards actually achieving that zero trust philosophy. So what is zero trust? Well, here's how Google defines it. And I use this particular definition straight from the Google Cloud website because it's one of the better ones that I've seen. So in case anybody is working on a small screen device, what it says is zero trust is a security model used to secure an organization based on the idea that no person or device should be trusted by default, even if they're already inside an organization's network. A zero trust approach aims to remove implicit trust by enforcing strict identity, authentication, and authorization throughout the network, not just at a trusted perimeter. In this model, every request to access resources is treated as if it comes from an untrusted network until it has been inspected, authenticated, and verified. So in other words, we're not just trusting anything because, well, it should be trustworthy. We're checking and rechecking and verifying all requests just to make sure that they are what they say they are. So just to kind of go back, I want to talk for just a second about that first sentence of this definition. Zero trust is a security model used to secure an organization based on the idea that no person or device should be trusted by default, even if they're inside of an organization's network. Maybe this part of the definition isn't quite as relevant today because our networks are so spread out, but for a long time, especially for those of us who have been in IT forever, there's often this mindset that, okay, if something's in our network, we put it there. You know, that user is an employee of the organization, the device that they're working from is something they use all the time, it should be trustworthy. Zero trust totally breaks away from that model, and it actually assumes that everything is out to get you until proven otherwise. So why does all of this matter? Well, there are quite a few reasons, but Google says that, unfortunately, their traditional approach offers little defense if attackers gain access to a network. Once in, attackers can move freely and attempt to extend their access to high-value data and assets, a technique known as lateral movement. Today, this is even more problematic in modern IT environments as resources and data are spread out, making it difficult to implement security control over a network from a single point. And then they go on to say that a zero-trust approach can help companies strengthen their IT environment security and help them to limit or prevent attacks. So let's put this into context. Imagine for a moment that an organization has an office building, and they have employees that go to that office every day, and they've got a security guard or a receptionist that's sitting at the front desk, and they check employees' IDs on the way in. But once that employee comes into the office, and once they've checked in with the security guard or the receptionist, at that point they have the freedom to roam the building at will. They can go anywhere, do anything. There aren't any more checks in place because at that point the employee has already proven their identity and they've proven themselves to be trustworthy. So there's no reason for anybody to check up on them. It's just at that initial point of entry. Well, that particular idea really isn't all that different from the way that a lot of networks work. Because think about the way that Windows domains work. When a user logs on, they enter a username and a password, and they're given an authentication token, or an access token, rather. And once they've got that access token, they can roam the network and attempt to access resources. And when they do attempt to access resources, their device checks the access control list for that resource. They provide that token, and if there's a match, then they're given access to the resource. If not, or if there is no match, then they're denied access to the resource. It's a fairly simple approach. But the thing is that as long as the user remains active, there's nothing that's going to force that user offline, nothing that's going to end that user's session. So they've been given that access token, and that access token remains valid for as long as that user is logged on. There's nothing there to check to see if maybe the permissions assigned to that user have been changed over time or something like that. The user can roam the network at will. So that's kind of the conventional non-zero trust way of doing things. So how would this analogy work in a zero trust world? Well, in a zero trust world, the employees come into the office, they still check in with the receptionist at the front desk, but at that point, they don't necessarily have freedom to roam about the building at will. Instead, maybe there's a lock on every single door and the employee has to scan their key card in order to gain access to that room. So at each point along the way, every movement that they make, they're reestablishing their identity, and there's a check to make sure that they actually have the permission to go into that room. So it's not a 100% perfect analogy, but it's a really good analogy for explaining how zero trust works, especially with some of the principles behind zero trust that I'll be talking about a little bit later on. So what are those zero trust principles? Well, there are any number of different principles depending on who you ask. Everybody seems to have their own idea. These came from Google. So the first principle behind zero trust is assume all network traffic is a threat at all times. Now, this goes completely counter to the way that network access is normally done. Remember what I was talking about. A user logs on, they're given an access token, and then they can roam about the network and access resources based on the contents of access control list. So at that point, once that user has logged onto the network, they're proved to be trustworthy. But in zero trust, this whole model is flipped on its head. The idea being that all traffic is considered to be hostile unless it's been proven to be trustworthy. So the second principle behind zero trust is enforced least privilege access. So the idea behind least privilege access, and this is something I'm going to be coming back to several times throughout this presentation, but the idea behind least privilege access is that a user shouldn't have access to anything that's not absolutely required in order for them to do their job. Some organizations take this to the extreme and actually make it really difficult for users to do their job, but the idea is that the user should have exactly what they need, nothing more, nothing less. Because really, why should a user have access to something that they don't even necessarily need in order to complete their job? That's kind of the business way of looking at it, but from a security standpoint, there are a couple of other considerations. Google talks about least privileged access primarily from the standpoint of preventing lateral movements by an attacker. And yes, that is something that can be important. I tend to look at least privileged access as more of a tool for reducing the blast radius of an attack. Because let's suppose for a moment that you've got an end user and they get a phishing email and they click on a link within that email and it unleashes a ransomware attack. Well, that ransomware attack, just like anything else, has to have certain privileges in order to operate on your network. So where does it get those privileges? Well, the ransomware acts under the same privileges as the user who executed the ransomware. So if that user doesn't have access to much, then the ransomware is not going to be able to touch all that much. Ransomware, in other words, is not going to be able to encrypt or compromise anything that the user who is running the ransomware doesn't have access to. So that's one of the big reasons behind enforcing least privileged access, is because if a user does trigger a ransomware attack or some other type of malware attack, or if the user's account gets compromised, it's going to limit the amount of damage that can be done. Least privileged access is also really important for reducing insider threats, because you just never know when you might have a disgruntled user who wants to do harm to the organization, and the amount of harm that they can do directly correlates to the amount of data that they have access to. So just something to think about. And then principle number 3, always monitor. So the idea being that there's an old saying in cybersecurity that you can't secure what you can't see. So it's really important to set things up so that you have visibility into your entire network and you can monitor everything, because if you can't see it, how are you going to know if it's secure or not? And it's important to not just be able to see and monitor all areas of your network, but you also want to log everything, because a lot of zero trust security comes down to looking for patterns of things that are abnormal, because oftentimes those abnormalities are going to be what signals that an attack is happening. And you can use all of that logging data as a way of determining what's normal versus what's abnormal. So what are some benefits to using the zero trust model? Well, there are quite a few. The first one is something that I just talked about a second ago, increased visibility. Because remember, you can't secure what you can't see. So if you're working to make sure that you're able to monitor your entire network, you're by default going to gain increased visibility. And this not only helps with security, it can also make your network easier to manage, and it can make it easier to troubleshoot any problems that may come into play on your network, simply because you have better visibility into everything. Another benefit is that you're able to better limit the blast radius of breaches. And this goes back to what I was talking about a moment ago with regard to least privilege access. Ransomware can't compromise something that the user who triggered the ransomware infection doesn't have access to. So the less users have access to, the less data that could potentially, or the less damage that could potentially happen if the user's account is compromised, or if the user unleashes a malware attack or something like that. Another benefit, access control in modern IT environments. So what Google says is, with zero trust architecture, security policies are based on identity and associated with specific workloads. This puts security close to the assets that are being protected, allowing it to travel with the workload regardless of the environment. Now, I tend to think of this one in a slightly different way. I tend to think of this as being less about security and more about practicality. Because stop and think about this for a moment. We're talking about zero trust in cloud environments. Now, most organizations aren't just operating in the cloud. You have a multi-cloud environment, if not a hybrid multi-cloud environment. And one of the concepts behind hybrid multi-cloud and multi-cloud environments is that of workload portability. Because just because your workload is running on a specific cloud today doesn't necessarily mean that that's going to be the best place to run that workload tomorrow. You know, the cloud providers could change their pricing structure at any time, so tomorrow it may be cheaper to run a particular workload on a different cloud. Likewise, there may be a cloud provider that introduces a new feature that can greatly benefit your workload, and you may want to move that workload over to that other cloud to take advantage of those new capabilities. There are any number of reasons why you might want to move a workload from one cloud to another. So that's what all of this is really getting around at, is that if you're binding the security to an individual workload as opposed to centrally managing it, then the security goes where the workload goes. So if you're working toward having true workload portability so that you can move workloads on demand as it makes sense to do so, then using this type of security will make it far easier to achieve that workload portability. So what else? Okay, the next one is consistent, adaptable security. And what Google says is that security policies are centrally managed in zero trust models and rely on automation to help migrate and update policies according to context. Security becomes more agile and scalable while also reducing the burden on administrators. So what this one really comes down to is the idea that it's a good idea to implement automation as a part of your overall security. We've all heard of the concept of infrastructure as code. Well, there's also something called security as code, meaning that you can create a file defining what it means for a resource to be secure, and then use automation to not only apply that security to your various resources, but also to check for configuration drift, to make sure that things haven't happened that are lessening the workload security. So automation can help you with applying security, maintaining security, and it can also help you with the monitoring process. You can use automation to pick out anomalies that might signal that a security threat is taking place on your network. The next benefit is reduced attack surface and risk. So there are any number of different ways that you could think about this one. What Google says is that Zero Trust isolates traffic and creates network segments that prevent lateral movement and stop any potential infections from spreading to critical resources. Any suspicious activity can be inspected and identities re-verified again with policies and controls, decreasing the chances of a successful breach. So what this is really saying is that you should put infrastructure in place so that if you do detect a threat, that threat isn't just allowed to run rampant. You can lock it down, isolate it to a specific area, and then deal with it there, as opposed to that threat having free reign of your network. So another benefit that Google talks about is continuous compliance. And what Google comes out and says is something that I think doesn't get nearly enough attention. You know, we all talk about the importance of adhering to regulatory compliance and legal requirements and making sure that we're doing everything that is necessary to keep our organization out of trouble. But Google actually takes it one step further on this slide, and they talk about something that is important and yet I don't often hear people bring up. So what they say is that under Zero Trust, all traffic and requests are logged and evaluated. In addition, it locks down access to resources. This not only provides a clear audit trail if a breach does occur, but it makes it easier to prove that you've done everything possible to meet data privacy requirements and standards. So why does this matter? Well, oftentimes, if a security breach does occur, then the aftermath of that breach is horrendous. There's often tremendous financial loss for the organization because they may get fined by regulators. Oftentimes, if personally identifiable data has been compromised, then they have to provide insurance to potential victims whose identities were compromised during the attack. There's all sorts of things that an organization may have to do. So using this Zero Trust model, what this is saying is that, one, we're assuming everything is hostile. We're assuming that an attack is going to be inevitable at some point. So we're already taking steps for dealing with that up front before anything ever even happens. So that way we're in a good position. And part of that is being able to demonstrate to regulators, authorities, whoever we may need to demonstrate to, that we've taken every reasonable step to ensure the privacy of our data and to prevent breaches, and yet this breach happened anyway. Now, this might sound trivial, but in a situation where you're dealing with regulators, if you can prove that you didn't breach any of the compliance mandates or violate any of the compliance mandates, rather, and that you took every reasonable action, you didn't do anything wrong, oftentimes you're going to get off with a much lighter, I don't want to use the word sentence, but a much smaller fine or less of a penalty than if you were found to be negligent. Okay, so let's talk about some of the challenges associated with using the Zero Trust model, and there are quite a few. The first one is being consistent. And what Google has to say about this one is that done right, Zero Trust can provide superior security as advertised. However, it also requires that organizations be consistent with strategy. Most organizations will need to make changes in stages as they shift away from traditional security solutions, but they will also need to ensure no gaps develop along the way. So what this is really saying is that Zero Trust isn't one of those things you're going to be able to implement overnight. It's going to require a lot of time, a lot of work, and the idea of being able to just implement a bunch of new security mechanisms and flip a switch and instantly switch over to a Zero Trust model, that's just not realistic for most organizations. So because there is that gap, Zero Trust implementation is going to be gradual. And so it's important to verify along the way that the new security mechanisms that you're putting into place are doing what they're designed to do. And it's also important to verify that you're not creating any new gaps in security along the way. Because remember, part of that transition process involves shutting down existing security mechanisms. And when you shut those security mechanisms down, there is a very real risk that you're opening yourself up to vulnerabilities, because that mechanism is no longer protecting whatever it was that it was designed to protect, and you're now relying on the new mechanisms that you've put into place as a part of that zero trust framework to do the job of the mechanism that you're taking offline. So it's super important to verify that whatever you're implementing is taking the place of whatever you're shutting down, and that you're not creating gaps along the way, even temporary gaps, because you don't want to leave your network unprotected at any point. Now, another thing that I take away from the idea of being consistent is that extreme consistency is going to make it a whole lot easier to secure your network and to spot anomalies. One of the examples that I often use behind this is the table games at the Las Vegas casinos. Now, I'm not really a gambler or anything, but one of the things that I've always found fascinating about the way that the casinos in Las Vegas do things is that anytime that you go to a casino, the dealers at the various table games are taught to deal the games in an extremely uniform manner. In other words, the way that they move their hands is uniform and it's scripted. The gestures that they make are scripted. Even the placement of the cards on the table, all of that is designed to be extremely uniform. And that holds true from one table to the next, from one game to the next, and from one dealer to the next. And the reason why these casinos do that is because it makes the dealer's behavior absolutely 100% predictable. Now, that's not to say that the outcome of the game is predictable, but the dealer's behavior, the motions that they make, and the way they deal the cards is totally predictable. And because it's predictable, that means that anything abnormal is going to stand out and become a lot easier to spot. And you can apply the same principle to IT security. If you're super consistent with the way that you do things, then any abnormalities are going to be far more pronounced than they otherwise would be. And it's going to be easier to spot those abnormalities and then begin to look at them and see if they might be attributed to an attacker doing something within your network. So the next one, inhibiting productivity. The idea behind this one is really, really simple. There is a list of rules called the 10 Immutable Laws of Cybersecurity, and there are quite a few variations on this list. But one of the laws, and I'm paraphrasing here, is that your users are never going to actively participate in security unless the secure way of doing things is also the easy way of doing things. Now, what does this mean? Well, what it really comes down to is that most users regard IT security as one of those things that just gets in the way. They tend to think of IT security as meaningless bureaucracy. It's one of those things that they have to deal with but would rather not. And it's just one more pain point throughout their day. And so if an organization goes about and begins adding a lot of additional security measures, and those measures only serve to make the users' lives more difficult, then the users are going to start looking for ways to circumvent those security procedures. Because remember, the user just wants to come in, do their job, and go home. They really don't want to have to deal with all of the extra stuff. And a lot of times users will view these security mechanisms as being either unnecessary or something that's the IT department's job, not their job, or something like that. So all of this is to say that if security becomes too disruptive or places too many demands on the end user, then the end user is going to try to find workarounds. And this can lead to shadow IT, it can lead to compliance violations. There's any number of things that can happen as a result of this. So you've got to strike a balance. You've got to maintain that security that you really need in order to keep the organization safe. But at the same time, you don't want to put so many measures into place that it makes the users or the end users' lives rough, and that the end users are going to look for ways to get around that. So it's important to try to strike a balance. So what are some more challenges? Well, another challenge is that of combating insider threats. So Google comes out and says that Zero Trust can help mitigate attacks through, or can help mitigate insider attacks through least privilege access. And it's not a silver bullet, but it can help. But having said that, it's not a perfect solution, because you limit the amount of data that an end user can access through least privilege access, but that doesn't mean that they can't launch an attack against your organization nonetheless. They might not have access to everything, but they do still have access to some of your data. So in order for Zero Trust to be effective against these types of threats, you need to have that monitoring system in place and to be able to look at patterns that might signal something's going on. It's easy to think of this pattern matching as looking for an attack coming from the outside, but it can also be used to monitor for and detect attacks coming from the inside from trusted users who have decided to go rogue. Maybe they've got some sort of grievance against the company and they decide to steal data or sabotage your IT systems as a way of getting even. So look for ways to use pattern matching as a way of spotting these types of abnormalities. Now, what types of pattern matching? Well, things like users trying to access things that they wouldn't normally access or going places on your network that maybe they wouldn't normally go to, things like that. And that takes us into the next one. The next challenge is maintaining policies and architectures. And I tend to think of this one as just the simple idea that security is not a set it and forget it proposition. If you really stop and think about it, attackers are using new techniques, new tools, and new methods all the time. So attacks are evolving. The attacks that we have today aren't the same as the attacks that we had 6 months ago or a year ago or 2 years ago. The attackers are always coming up with the new things. And it's not just the attackers that are changing. Technology is also changing. Think about all the AI-based attacks that are happening now that would have been unthinkable a few years ago. So you can't just put security into place and say, okay, everything's secure, it's as good as it can possibly be, so therefore it's secure forever. It doesn't really work that way. So one of the challenges that Google is laying out here is maintaining your security policies and your security architecture so that it keeps up with all of these changes that happen over time. So what about some Zero Trust best practices? What are some things that we can do to make sure that we're implementing Zero Trust in as effective a manner as possible? Well, there are countless best practices, way more than I would even have time to cover in this presentation. So I've pulled these various best practices from a variety of sources across the web because I think that they're some of the more useful best practices that are out there. And some of these are kind of rehashes of things that we've already talked about, but I went ahead and left them in just because they're important. So let's talk about some of these. Okay, the first one on the list is monitor network traffic and connected devices. And this goes back to what we were talking about earlier about the need for extreme visibility in order to maintain a Zero Trust architecture. Visibility is crucial. And remember, the whole essence of Zero Trust is that you need to be able to verify users anytime they access a resource. But oftentimes it's not just the users that you're verifying, it's also the machines that they're working from. Because if an end user who is trustworthy and isn't trying to do anything bad happens to access your most sensitive resources from a PC that's riddled with viruses, well, then bad things are probably going to happen as a result of that. So it's not just the end users that you need to verify, it's also the devices that the users are working from. So that's a part of where that visibility or the need for visibility comes into play. So what else? Well, the next one on the list is keep devices updated. And in a way, this is one of those that really seems almost needless to mention because we're all aware of the need to keep devices updated. As I mentioned earlier, security threats change over time. Attackers are constantly finding new vulnerabilities in software, and any reputable software manufacturer is going to periodically release updates in order to correct any vulnerabilities or bugs that may have been discovered in their products. So it's important to make sure that those vulnerabilities get patched as soon as possible. But beyond that, it's also important to be able to restrict access to vulnerable devices. And that's another big part of why monitoring is so important. You've got to have visibility and to be able to tell what devices might be vulnerable versus what devices aren't necessarily as vulnerable. So what's a vulnerable device? Well, this might sound a little snarky or smug, but it's whatever you say it is. Because ultimately you're the one who sets the rules for your network. So it's up to you to decide what devices you want to allow to participate on your network versus which ones you think it probably isn't in your best interest to allow. So let's talk about this a little bit more. The last few years, work from home has become far more pronounced than it ever was in the past. Certainly we had bring your own device long before work from home, but even now, several years after the pandemic, there's still a large percentage of users who are working remotely from personal devices. And these personal devices vary widely, as I'm sure you all know. You may have some users who are working from carefully curated corporate-owned PCs, but you've got other users who are working from personal tablets or smartphones, maybe even shared devices. The same device that they use for work is the same one that their kid plays games on in the evenings. So you've got all manner of devices that are accessing your network. So it's important to set up some criteria that defines what you consider a device to be healthy. So what might some of those criteria be? Well, if we're talking about mobile devices, you might look at, is the device jailbroken or not? Is it running an up-to-date operating system? Is there any software on the device that is known to be problematic? Those are just a few things that you might look for. If we're talking about PCs, does it have the latest patch? Has a malware scan been done? So there are all of these things that you can look at to determine, is the device healthy and do you want to allow it onto your network? Now, there's one more thing that I want to talk about this before I move on. And that is that there's a difference between allowing a device on your network and allowing a user to access a resource from that device. So the reason why I bring this up is because sometimes you may want to create a policy that will allow a user to access a resource based on what type of device they're working from. So let's suppose you've got some data that's super, super sensitive, and you've got a user who uses that data all the time. They're authorized to access that data. There's no problem there. But that user is going to be working remotely, using public Wi-Fi in an airport from a device that their kid plays games on in the evening and that several other people share. You don't really know all that much about that device, and it's probably not in your best interest to allow the user to access that super sensitive resource from that device on public Wi-Fi that the organization doesn't even own. But on the other hand, when the user comes into the office and they log on from a domain-joined PC that's owned and maintained by the company, well, that PC is pretty secure. So maybe you want to put a policy in place that will allow access to that sensitive data from the domain-joined PC, but not necessarily from the shared iPad on public Wi-Fi. Whereas other data that's less sensitive, maybe it's not a problem for them to access it from that remote device that they own personally, simply because you are taking steps to verify that the device is healthy. Just maybe you don't want to allow it to access your most sensitive data. So these are all things that every organization would have to decide for itself, but I just wanted to give you something to think about. So let's get into some more best practices. Another best practice is applying the principle of least privilege for everyone in the organization. And again, this is something that I've talked about several times already, but it is important. And the thing that I liked about this particular quote from Cloudflare is that it goes the extra mile and talks about that least privilege access is important for everybody. And that includes executives, IT teams, end users, everybody. Because remember, at the end of the day, anybody can have a bad moment and click on something that they're not supposed to. Certainly I've made that mistake. I've clicked on something. Thankfully, I caught my mistake before any damage could be done. But it could happen to anybody. So it's important to limit the blast radius for every account, regardless of who that account belongs to. IT probably shouldn't have access to absolutely everything in the entire organization from one single account, just because of the risks that creates. So you want to think about the damage that could be tied to any one individual account should that account be compromised, and then take steps to limit that potential damage. Another best practice, partition the network. And this one came from Cloudflare. And what they have to say is that breaking up the network into smaller chunks helps to ensure breaches are contained early before they can spread, and that microsegmentation is an effective way to do this. So in other words, if a breach is happening, maybe you can shut down that one network segment and isolate the area that breach is happening in so that it doesn't spread to the rest of your network. Okay, another best practice is act as if the network perimeter did not exist. Now, in many ways, this particular recommendation seems super outdated, but I wanted to go ahead and include it anyway just because it is so important. At one time, the way of thinking was totally different with regard to network security. And I find that this is still prevalent with old-timers like myself who have been in IT forever. Because at one time, the mentality was, all of my assets are included in this building. The users come in here to work. All of my workloads are in the data center that's also in this building. So if I can keep the bad guys out and I can keep any of my data from leaving the organization, then everything's secure and I've done a good job. But today it doesn't work like that at all. I mean, if you think about it, we have users working from virtually any device type and from practically anywhere. We have workloads running in our data center, but we also have workloads scattered across who knows how many different clouds. So in a lot of ways, the network perimeter doesn't exist. And, it is possible to make the case that, yes, there is still a perimeter, but if that perimeter does exist, it's pretty much like Swiss cheese, meaning that it's full of holes that lead to the outside world. So it's best to just pretend that the network perimeter doesn't exist at all and treat the assets on your local network within your organization as though they were coming in from the outside world. Another best practice that came from Cloudflare is use security keys for multi-factor authentication. And they go on to say that hardware-based security tokens are demonstratively more secure than soft tokens like the one-time passcodes that are often sent over SMS, text messages, or email. And I agree with this one 100%. I don't really have time to get into a detailed discussion of it today, but the one-time passcodes that are often sent by websites through text messages or email as a way of verifying your identity, there are quite a few different documented ways of beating those types of MFA challenges. They're not nearly as trustworthy as most people tend to think that they are. Security tokens, on the other hand, the hardware-based MFA keys, those are way harder to fake. So those go a long way towards improving multi-factor authentication security. Now, the other reason why I wanted to talk about this just a little bit is because I've read some articles online, maybe not super recently, but I have read some articles equating the use of multi-factor authentication to zero trust. But remember what I said at the very beginning of this presentation. Zero trust isn't a product that you can go out and buy and all of a sudden you're zero trust. It's not a service that you can subscribe to. It's a framework. It's a mindset. It's a way of doing things. So multi-factor authentication might be an important step in achieving zero trust. It might become a very useful mechanism to use in your zero trust framework. But multi-factor authentication isn't the same thing as zero trust. It can be a part of zero trust, but it doesn't make up zero trust all on its own, like some of the articles that are out there suggest. So what's another best practice? Another one that Cloudflare recommends is incorporating threat intelligence. And the idea being that attackers are constantly honing their techniques. They're making use of new technology, new mechanisms. So it's a good idea to subscribe to the latest threat intelligence data feeds, because that way it allows you to stay up on what attackers are doing, so that way you know about these various methods and know how to counter them before an attack has a chance to happen on your network. Another best practice, avoid motivating end users to circumvent security measures. And I'm not going to go into this one too much because it's something that I already talked about. But again, the idea being that if your security requirements are overly cumbersome for the end users, then it's an absolute fact that most users are going to look for ways of getting around those security requirements. What I liked about this particular best practice that I took from Cloudflare is that they actually provide an example. We talked about that with zero trust. One of the things that you do is that you verify that users really are authorized to access a resource just before they access that resource. So in other words, you're not assuming that just because the user already logged on that everything's good. You're verifying and re-verifying the user's permissions to gain access to a particular resource. So what they're saying is that forcing a user to re-authenticate once an hour or using multiple authentication factors, that can end up putting too much of a burden on the end users. And you might actually lessen your security by doing that just because the end users are going to look for ways of working around those requirements. So another best practice, and I love this one because it's one of those things that you don't really hear talked about very often, but the best practice is terminate every connection. So here's the deal behind that one. Technologies like firewalls are generally used in a pass-through manner. In other words, there are certain ports that are open. The traffic goes through those ports into your network. Depending on the type of firewall, sometimes there's an inspection that goes with the traffic. maybe we're looking at more than just the port. We're also looking at which application the data is associated with, things like that. But what Zscaler is saying in this quote is that it's a good idea to not just pass traffic through a firewall, but actually to terminate the connection and use the firewall like a proxy that terminates the connection, it inspects the packet, and then if that packet is found to be on the up and up, then it goes ahead and regenerates the packet and sends that on to its destination. And it should do this even for encrypted traffic, and it should do it in real time, because this will go a long way toward keeping ransomware and other threats out of your network, because you're actively inspecting all of that traffic coming in, and you have a way of stopping it before it reaches your network. Another best practice, reduce risk by eliminating the attack surface. And this actually goes back to something that I talked about in my most recent webcast. I don't know if any of you were in on that one, but last month I did a presentation on the security risks that were associated with VPNs. And one of the things that I talked about in that particular webcast is that the whole VPN way of doing things is really different from what the software as a service provider do. So if you think about the way that a VPN works, imagine you've got a user who needs to access a certain workload on your network, and they're working remotely, and they need to connect through a VPN. What they would do is establish a VPN session. They get on your network. Your VPN server checks and makes sure they adhere to all of the health requirements and the authentication requirements. And assuming all that's good, then there's a DHCP server that gives them an IP address, and then bam, they're on the network. From there, they can go wherever it is that they need to go in order to access the application. Well, then on the other hand, we have SaaS providers, software as a service providers, and they do things completely different. You don't connect to a software as a service application through a VPN. Instead, what you do is you open up a browser and go to a web front end and then access the application through that. So think about the fundamental difference here. Because a web front end is being used, those users never touch the back-end network. There's no reason to establish a VPN connection. There's no reason to traverse the network. So end-user traffic is never even touching the network. It interacts with that front-end server, but that front-end server acts as a proxy sending data to the back-end. The end user never touches the back-end directly. So what Zscaler is saying with this best practice is that it's a good idea to look at how that's being done and to look for ways of incorporating that on your own network. Eliminate end-user network access on the back end wherever you possibly can, and focus instead on keeping end-user traffic separate from that. Another best practice is accept that IP addresses cannot be trusted. A lot of times, if we see that an IP address originated on our network, there's a tendency to trust that. We assume that, okay, that IP address is local to my network. It must have been generated by my own DHCP server. The user must be local to my network. Therefore, I can trust it. You really can't, however. There's any number of reasons for that. For one thing, it's super easy to spoof an IP address. But also, it's tough to know where an IP address really came from, because a lot of times IP addresses are used dynamically, especially as we start talking about virtual machines and Kubernetes and things like that. So what that really comes down to is that you can't necessarily tie down an IP address to a specific device or to a specific user. And that's a problem because a lot of security products do take that approach. But it goes a little bit further than that. Let's go back to the example that I was talking about earlier with a user who needs to connect to a network via a VPN. As I mentioned, the end user has a client that's running on their device. They open up the client, they establish a VPN session, and then they provide their credentials. At that point, those credentials are verified. There may be a health check that is performed to make sure that the end user's device is compliant with any health requirements. And then at that point, that end user's device, or at least their session, is given an IP address that was provided by a DHCP server connected to the VPN server on the organization's network. So what that really means is that the user is working remotely, but because of the nature of the VPN session, they're using a IP address that adheres to a certain subnet on your network. So that comes down to the question of, should you really trust that IP address just because it was generated by one of your own DHCP servers? Because think about it at this point. That user is remotely. Yes, they've provided authentication credentials, but really You don't know anything about them. That user could be using stolen credentials for all you know. So you can't necessarily trust the IP address associated with that session and assume that everything associated with that session is good just because that IP address was issued by your own DHCP server. So this really just goes back to the whole notion of not trusting anything. So what else? Another best practice is to look for tools that can work across multiple clouds. Early on in the presentation, I talked about the importance of visibility. And in hybrid cloud environments and multi-cloud environments, this can be really tough to achieve just because each provider does things a little bit different. So look for those third-party tools that will give you visibility across your clouds and that will allow you to apply security policies in a super consistent manner regardless of which cloud a particular workload is running on. So the last thing that I want to talk about is AI and next-generation technologies and how they're changing the threat landscape. So you have to consider not just the threats that are lurking on your network, but also things like social engineering attacks, particularly against your help desk. One good place to start is what does it actually require for a user to have their password reset? Now, if you're using a Microsoft environment, Microsoft recommends that you enable self-service password reset so that way users are able to reset their own passwords without ever having to talk to anybody at a help desk. But let's suppose for a moment that you don't have that enabled, or perhaps you have a user who just doesn't trust self-service password reset and they want to do it through the help desk. Well, what kinds of threats exist as a result of that? For example, can your help desk be subject to a social engineering attack? Can somebody call the help desk posing as a user and convince them to change the password on an account, thereby giving that attacker access? So what's really required in order for a user to have their password reset? Well, there are a few things to think about. First of all, there's the password reset process itself. For starters, does the help desk technician have the ability to reset a password under any circumstances? In other words, let's suppose you have a rogue help desk technician. Can they change a password on a user's account without having been asked to do so? Maybe they want to gain access to that account themselves, so they pretend that a password reset request came in and they changed that account's password, thereby giving them the ability to access that account. Can that be done, or do you have a mechanism in place to prevent that? Another thing to consider is, let's say that a user does call the help desk and request a password reset. Can the help desk be fooled into complying with a false request? I'll get into that one in just a little bit in a second, but another thing that I want to consider is, let's say that a legitimate user calls the help desk and asks to have their password reset. Are there any risks associated with that process? For example, how does the help desk go about verifying the end user's identity? Typically, that's going to be done by some sort of multi-factor authentication process. The help desk might send a code to the user's phone, but oftentimes that's just a first step. There may be another factor of authentication that's needed in order to prove the user's identity, and this might come down to a security question. The problem with this is that if you are asking, if the help desk technician rather is asking the user their security question, the user answers that question. At that point, the help desk technician knows the answer to the user's security question. So just something to think about. But let's get back to this other point. Can the help desk staff be fooled by a phone call? Well, you have to consider the advances in AI, because AI makes it impossible to impersonate anyone over the phone in real time. This is something that we're starting to see more and more of. All an attacker needs is a relatively small sampling recorded of someone's voice in order to use AI to impersonate that person. Now, early on, these impersonation capabilities really weren't all that great. I remember, I don't know, maybe 2 or 3 years ago, seeing a demo in which someone took some recorded samples of some American politicians and used AI to impersonate them. And, it was good, but it wasn't super convincing. Something just seemed to be off, and it was easy to tell that it wasn't that person. Well, AI has gotten a lot better. And more problematic is the ability to use AI to generate voice in real time, meaning that an attacker can actually place a phone call, have a conversation with someone, but make themselves sound like someone else in real time. And this isn't just being directed against corporate networks either. Someone in my family, not all that long ago, received a phone call posing as my brother. They impersonated his voice perfectly, from what I was told. And the only reason they knew it wasn't him was because they were making some outrageous requests that my brother would never make. But the audio was completely convincing. So just something to think about. And the same also applies to deepfake video, because I've heard it suggested like, okay, phone calls aren't trustworthy anymore. Maybe we can require a team session or a Zoom session just so that we can see the user face-to-face and ask them, is it you who is making this request? Well, the problem with that is that deepfake videos have come a long way, and I haven't heard any stories of anybody using a deepfake over a team session or a Zoom meeting or anything like that. But that's not to say that it's impossible. There may very well be a way to do that. So I'm getting super close to being out of time. I'm actually a little bit over, but one last consideration is that large language models, I'm talking about things like are models that are like the ones in use in Microsoft Copilot and ChatGPT and things like that. They make it possible for criminals to compose text that's far more convincing than might have been the case in the past. So, you know, it's easy to think of someone asking ChatGPT or Microsoft Copilot, hey, write a block of text that asks for this. But what a lot of people don't think about is that there are ways of tuning that text. For example, you can say, write this in the style of, and if the large language model knows enough about the person that they're trying to mimic, then you can have it write something that mimics that person's writing style. I was playing around with this not too long ago. I asked for a block of text from classic literature, and then I said, okay, rewrite this in the style of, and then started listing several different prolific authors. And it was fun to watch how AI changed the text to make it sound like different people. Again, it's not perfect, but it's getting better all the time. You can also ask AI things like, make this sound more professional. So, you know, currently a lot of phishing email messages are really easy to spot because they're filled with bad grammar and misspellings. Well, if someone who is composing one of these messages were to ask a large language model to make that sound more professional, well, then it's going to be a lot harder to spot that phishing message. And then one more thing that I haven't heard of an attacker doing, but that's easily possible, is to write a paragraph and then tell the large language model, hey, rewrite this, but do it in a persuasive writing style. That way, if they're launching a social engineering attack, so to speak, then they're making that text as persuasive as possible in an effort to maximize the chances of that attack succeeding. So with that said, it's super important to look for areas in which in which your security might be circumvented by someone who's relying on next generation machine learning technologies. And I don't even know if I have any time for questions, but I'll turn it back to Gladys just in case.
Yeah, I want to get one question into you, Brian, from Kevin, who asked, how do you overcome silos? For instance, routing can segregate a network who can go where, while Active Directory sets up login and access groups, and database admins limit who can see what. How do you ensure coordination?
Wow, that's a really big one. And I wish I had a specific answer for you, but the answer is going to depend, or it's going to vary widely depending on which technologies you're actually using. One place that I would recommend starting out, if you're working on the Microsoft Cloud, take a look at conditional access policies, because those might be able to do some of the things that you're talking about doing. I can't really say for sure because I don't know all of the specifics, but that might be a good starting point.